Here we're looking at deriving one of the equations of motion with graphical method. So we're going to derive position velocity relationship, that is v square is equal to u square plus 2 into a into s. The graph that we are going to use is a velocity time graph. So we have the velocity over there and the time over here. This is velocity versus time graph. So the object is going to move from, or not from, with a velocity of u to v during the time interval of 0 to t. So to identify where is t and v and all of that, we need to project the point B onto x and y axis. So this would be your time t, 0, and that is v. So here we are looking at an object accelerating steadily from u to v. So basically we are looking at an object within the time interval 0 to t has moved from v to u. So how do you find this particular expression? Let me complete this A, B, C, D by making use of the fact that S is nothing but area of the trapezium ABCD. So how does this trapezium look like? We have AO that is parallel to BC and OC. Sorry, it's not ABCD, it's ABCO. Okay, ABCO. Here AB is parallel to OC and this is perpendicular. So this would be equal to half into sum of parallel sides, that is AB plus OC, into the distance between the parallel sides, that is AO. Now what is AB? Oh my bad, that's not AB, this is OA. That would be O, whole thing changes, OA BC. So the sum of parallel sides is OA plus CB and the height is OC. Okay, now OA is nothing but your U plus CB is nothing but this entire line, that is V, into OC is nothing but T. We want an expression which is S being equated to, sorry, not S being equated to, V being equated to V square being equated to U square and 2AS plus 2AS. So for that to happen, there are quite a few things that needs to go. Time is not there. So what to do? We will get an expression for time. From where? We'll get an expression from U is equal to V is equal to U plus AT. So we have V minus U is equal to AT, right? And if I transpose A onto the left hand side, V minus U by A is equal to T. So if I happen to substitute in place of T this particular expression, let's see what happens. So we have S, okay, I'll write it here itself, half into U or V plus U, I'll just rearrange, into V minus U by A. What is, okay, let me rearrange all of this, 1 by 2, right, in the denominator, 2 into 1 into A is 2A. And in the numerator we have V plus U into V minus U, which is V square minus U square. And now we have S is equal to 1 by 2A V square minus U square. So 2AS is equal to V square minus U square. Rearrange this, 2AS plus U square is equal to V square. And that is your final expression, right? So we have the similar, actually not similar, the same diagram. The description of the diagram would be the same. We'll start off with talking about S being the area of, equal to area of trapezium, and then move on to this particular write-up. Okay, so first thing is we need to begin the answer with the diagram, the velocity time graph with the object moving from A to B. the object moving or increasing its velocity in a uniform way from u to v. So we'll begin with, consider the velocity time graph of an object that moves under the uniform acceleration a. Let the initial velocity of the object be u, and then it increases to v in the time interval t. So we need to drop BC, BE onto your velocity and time graph, and drop AD onto OC. So all this is in the diagram, very clear, nothing to worry about. Okay, so all this write-up is the same for all the three derivations. And now we have a similar statement. OCDA and OCBE are rectangles with opposite sides being equal, so we can equate all of these values. So DC is equal to AO, right? DC is equal to AO, which is equal to U. BC is equal to OE, which is equal to V, right? So that's V and this is U. And BE, which is equal to AD, which is equal to OC, is equal to T, as the opposite sides of the rectangle are equal. So now we'll begin the derivation talking about, let S be the distance covered in time t. So from figure, S is equal to area of OABC, the trapezium. We are able to equate this because in a velocity time graph, area under the graph is the displacement of the object, right? So with this fact, as in a velocity time graph, S can be equated to this. And area for trapezium is nothing but half into sum of parallel sides into the distance between the parallel sides, and then substitute the expression from the figure, and substitute those expression in terms of b, u and t. For those expression we are going to write in these terms, and we get this expression, substitute t, a similar set of step. So this is a neater write-up, that's all. Okay, so this would be your running notes. If you want any idea from here, you can take it. And for your exam, you guys have to write this.